So Jessica, just looking at the data that you sent me, in the file you'll find that there's these, in the head of the file here, you get, in a LandXML, you get a header file, and that header just tells you units and stuff like that. And then down here you'll get, they're giving you these COGO points, and so they're giving you every single point in the surface model as a 3D point. And so it has to import all of these points, and points just take a while to read and create. But all these COGO points, effectively you can delete all these because they're giving you them again further down. If I keep going down here, these points here that are listed in this form here, these are actually the points that are used to build the surface model. And then later on, these points get used to build the faces, which are the faces in the surface model. So when you look at the data here, they're giving you duplicate points, the COGO points, which are kind of unnecessary, but they get imported by TBC because TBC will read the whole data out of the LandXML file, as well as it will build the surface using these point IDs and the faces. So if you were just given the points and the faces, then it would build the surface much quicker than it would do if it has to read all the COGO points and create those. And so when somebody says they can read them into Civil 3D quicker, my guess is that they may be turning off the point import and so just bringing in the surface itself. Either way, I found it didn't take that long on my computer to bring it in, so I'm just going to do that to show you the difference. But if I take this file and I compare it with a file that I wrote from the surface that was imported, this is the surface model from TBC. These are the point ID list, and then down at the bottom you'll get the faces list, and that's all you need to build a surface model, right? So if I bring in that file that I just created, so if I just take that and read it into TBC, this is how fast it reads. It should just take a few seconds here to read, and then the tin model will be created and no COGO points at all because you don't need the COGO points whatsoever for this particular process. So there's your surface model, which is exactly the same surface as you created from your system or from the LandXML they provided you, but without the COGO points. So you don't, if you click on any of these points, these are vertices. There are no points at these locations after you import this file. And this file is now, perfectly good for working with. Now, one question, if you have a surface model and you have got the points or you need the points, one trick you might want to use is this command called surface to points, which you'll find in the modeling toolbox. And that surface to points command will let you pick the model, which in this case is called 0. I don't have any boundaries, so I'm just going to deselect that and then give it a file name. So I'm going to go in here and I'm going to go into your folder here, LandXML problem, and then just call it WSB surface point cloud. And then say save, and then I'm just going to say import that file back in again, and I hit apply, and what that will do is it will write this data out as an XYZ file, then bring it back in again as a US survey foot point cloud, and now I've got a point cloud over that whole surface. So if I turn off the surface model now, that's a point cloud that I'm working with, so it acts as one object. It's easy to select, and I can still go in there and regionalize it, reduce it, and make my own surface model out of that. So I could now take this point cloud, which is 120,000 points, and make a surface out of it, and that way I've got the benefit of having the point data as well as the point cloud, but the point data is in a much more efficient user bucket, if you like, than the COGO points would have been from the Topcon solution. And that's something I'll do very often with data, because then I can use things like our point cloud by boundary command. So I would use things like this, point cloud by boundary, and I could say, now I can say just pick a boundary, or I can define a boundary and then use it, and I can do that by using polygon select. So in here, if you want to build a boundary, then you would just click on a create boundary function. You would say, call it test or whatever, put it on a layer, and then you could say it's a polygon, and then you want to just draw around the outside of this model. Let's say this is the limits of the site. I'm just going to do a rough one just to kind of show you the idea. So if you don't need all the data in the original project, you can reduce it significantly by just doing this kind of thing, and then double click here and say close. And so that boundary line, what layer did I draw it on? I can't remember now, but let's just turn all the layers on here. So that boundary line is there. So now I can say pick that boundary line, and that will pick the point cloud data just within that, and then I can say make a surface out of that should I want to do it. So that's a way that I handle big data sets. And then I'll throw away the original surface they gave me and throw away the COGO points that they gave me, and I don't need it anymore. And that way I'm going to be working now with much more efficient data inside TBC than the original data. But if we just start another project and just show you the import of that data, again, if I say go create a new project, and then I go to your COGO file, or the file with the point data in it, so go to here and grab that WSB surface XML file, this one. This is your original data, and now it's kind of trying to bring it. You can see it says it's importing COGO points, and TBC's importer doesn't give you switches to say import this or don't import this, etc. It doesn't give you that. It just imports everything from the LandXML and then lets you sort it out afterwards. And that means it takes a little while longer to import the data than maybe you would want, because if you don't need the COGO points, it would be nice to be able to deselect it, I guess. But anyway, once it's come in, and it has to now render all this data graphically, and there's 120,000 individual discrete 3D points that it has to render, and that takes a little while in TBC. So at that point, once it's finished, I would just then delete all those points, because you don't need them, because you've already got them in the surface model. So this is, again, starting from the Topcon, import the LandXML, and then wait for it to finish. Just take a few seconds here. So now it's finished bringing in the surface model. There's the tin model, and the point data, the COGO point data, is on the points layer. So if I turn that off, then I don't need to see it, and it's going to work pretty efficiently as a surface model. So the surface is basically exactly the same as the one I just brought in, but you do have all these COGO points associated with it, which are additional data that was in the LandXML file, which we didn't shut off on import. But if you now turn off the surface model, you get left with the COGO points, and you can basically delete all those if you don't need them. So you just go here, delete them all. Now it'll take a little while for TBC to select 120,000 points, which is the time it takes to generate the visual rendering of all the points, because a point in TBC is not the most efficient object. It takes a while to select them and takes a while to move them, but a point cloud is much more efficient. So I would normally delete these points if they're just the triangle points, because you don't really need them. And again, it takes a little while for it to delete them all, because it has to delete each individual point from the database, which is a pain. And again, TBC is not so efficient at handling point data individually. But if I need the points, then I would just run that surface to points function again to convert the surface into a point cloud, and then the point cloud is highly efficient, and I can use parts of it to build a new surface model that I would then control, as opposed to using the imported point surface and points from the Topcon file. So again, you can't always trust the data from a third-party source. You have to kind of think about how you want to use it and get the most efficient data out of it. But you can see this is an extremely slow process in TBC to delete 120,000 points. But if you wanted to, you could also go into just a text editor like this one and open up that LandXML and take a look inside it. And if you know that that data is something you don't need, you can go into the Topcon file here, and if you find the COGO Points section, you can just go in here and go through all this until you find the bottom of the COGO Points section, which is, I'm going to have to find it. It's this on a big file. It's kind of tricky to find it in an editor like this. But if I go to the first line and just keep coming down here until I get to the bottom of it, and that's going to take a little while to do it that way. And you can probably just keep scrolling down, and then when you get to the bottom of it, you can use the shift key. But if I go down here, there's 120,000 lines of data there that I've got to get through. So I come down to the bottom of it here somewhere, and if you can find the bottom of the section, which is right here, you can effectively just delete that and just delete a blank line if there is one. You don't need the blank line. And then you've got the surface detail in the LandXML. So if I now say File, Save As, and I just call it, let's call it Topcon Rev 2 or something like that, and say OK, save that. Now that's got rid of the COGO points, and now I've just got the tin model and the surface detail at the bottom. So again, if I now just minimize this You can see it's still trying to select all the data over here. And that's what the sluggishness you're talking about is. I see that too. It doesn't matter how good a computer you have, TBC is just not very powerful at selecting large amounts of point data and deleting it or moving it or doing anything with it, to be honest, which is why I try to avoid working with point data completely. But again, this might take it a little while to kind of select all these, so I'm just going to pause it and I'll come back when it's finished, and then we can take a look at the rest of the workflow when I get back. So moving along, Jessica, I kind of, that file I just edited, if I go find that file, that Topcon revision 2 file, which doesn't have the COGO points in it, then it should import a lot faster this time, because now it's just got the surface model in it. So we'll take a look. You see it says here just importing surface 0. So while it's still a relatively big surface and it still has to create it and form the surface internally in TBC, it should handle it quicker than the COGO points. But you can see now, by deleting those points, I got rid of the COGO points, and now I'm in good shape. And then all I would do is I would take that surface and use that command I showed you before. So I'd go to modeling and surface to points, and then I would pick the surface model here and give it a name. Like that. And then I would say import the file again and say apply. At that point it then asks me for the units of the file, and there's my point cloud now. So if I click on a point here, it should pick up all the point cloud data. If I turn off the surface model, there's the point cloud data, and it acts like one object now, so it takes no time at all to select it, no time at all to delete it. I can georeference it to move it around. I can use the point cloud tools to reduce it, and then I've got something that's much more usable as far as TBC is concerned for most things. I have reported the speed issues with Trimble on the point stuff many times over the last 2 or 3 years. I haven't really got much traction with them around that, and so I don't know whether there's anything I can really do to help you around that. But anyway, hopefully this video helps, and hopefully it lets you do things a bit quicker. All right, thanks.